Okay, guys, listen up here. So you should find in the stream now or in the classwork section, okay, the acceleration lab, right? And in there, okay, same as before, you'll have the lab sheet, which is what I'll be working off of here in a minute. Okay, there's acceleration lab data, but I mean, you only need that if you're not here or your data is a total mess. Hopefully you won't need that. Okay, and then your lab report. Okay, and that's the file obviously you should have open right now because that's where you're going to put in some of the tips and hints that I'm going to give you here, okay, as we go along. All right, everybody find what they need. Almost. All right, so the lab's pretty straightforward, guys. We're just going to do one trial, okay? You only have to get one good trial, okay, where you have the cart accelerating smoothly down the ramp. So the data acquisition for this lab should really not take you very long, okay? And then it'll be building the graph, same as before. Okay, actually you're going to build two different graphs. You're going to build a position versus time graph and a velocity versus time graph, but it's only of one data set, so that'll be pretty straightforward. Okay, so the problem we're investigating here is the type of motion experienced by a cart rolling down an incline. Okay, spoiler alert, it might have something to do with the title. Right? Possibly. Okay. Now, remember that for the problem, you have to restate that in your own words in the form of a question, just like Jeopardy. Okay, you have to have that in there. Now, for our design, okay, manipulated variable, responding variable, controlled variables. Here are the variables. You'll have to decide which ones are which. Okay, the things that we will be measuring in this lab are time. We will be measuring position, and we will be measuring velocity. Right? Those are the things we will be measuring. Two of those variables depend on the other. You have two responding variables in this lab. Okay? You can, of course, only ever have one manipulated variable. Okay? The other two depend on that variable. Now, in terms of controlled variables, okay, the most important controlled variable in this experiment is the acceleration of the cart. Okay, controlled. So I'm giving you the controlled variable, one of the three that you need. Okay, we need that acceleration to be constant. If it's not, our graphs are just not going to look right. Okay, so we need the acceleration to be constant. That means your other two controlled variables should be things that could affect the acceleration. And there are two that should be pretty obvious. Okay, you can think about what might be pulling that thing down the ramp and possibly something else about the ramp, okay, that could affect the acceleration of the cart. I'm not verifying anymore. I'm just putting things out there for you, Ryan. Okay. For our hypothesis, okay, we want to have if, and then in there, okay? So to set this up, I would say that the if part of your hypothesis should tell me what accelerated motion is. Okay, give me like a definition of acceleration in the if part. I mean, after all, this lab is trying to prove essentially what acceleration is, so that's what the if part should tell us. Okay. The and part, as always, gives a brief description of the experiment. The velocity, position, and time of a cart will be measured as it accelerates down a ramp, or moves down. I guess we would say moves down a ramp. We wouldn't use the term accelerate in the and part. Okay. In the then part, I want predicted results. And what I mean by that are as follows. Shape of both graphs, and how you will calculate the acceleration from your velocity versus time graph. Okay. So in that way, the setup of this whole thing is very much like your last lab, except this time it's dealing with acceleration instead of velocity. Okay. Nice catch. That was close. I got some paper towel here. Almost got your phone. That was really close. Yeah, awesome. Okay, questions on the kind of pre-lab part of this? Okay, so give you guys some time to fill that stuff in later. Okay, for the procedure, you're going to build a setup similar to this, except you're not going to build it on top of a desk. Because if you do that, the cart will run off the desk and it'll break, and then I'll break you, and then we don't want that, okay? So we got to take care of things. We're going to build this on the floor where everything won't get broken, or hopefully won't get broken. Now, we won't be using these gray ramps because we only have a few of them. So you have these wonderfully, beautifully crafted wooden ramps instead, okay? They work great because Mr. Dickey and I spent like the last week of our summer vacation making them. So they're going to work just fine for you. Okay, you will use the black carts, okay, along with them. They're made so that the black carts fit perfectly in the slots. Okay, you'll put the motion sensor right on the top of the ramp. It will not clip to the ramp as it shows in the picture because obviously that ramp is different than this one. So you'll set it on top of the ramp and just make sure it's aimed at the cart. Okay, the rest of it is going to be just like your last lab. Okay, you'll use the same app you did before. Okay, you'll start and stop it. Okay, so you'll say start, the person will let the cart go and it'll accelerate down the ramp. When it gets to the bottom of the ramp, stop recording. Okay, we only want the data for while it's on the ramp. Once it leaves the ramp, what's it going to do? It's going to start to slow down. Plus there's going to be the part where it kind of jumps off the end of the ramp here, and that's going to look funny on your graph. So, okay, you'll know what part of the graphs you want. Okay, for both position and velocity versus time graphs. So it's pretty straightforward. One run, okay, and you'll be able to tell from your graph whether it's right or not, okay, just by looking at the shape. If it looks right, then you're good. You don't need to do a second run. You can put everything away. All right, everybody follow me on that. A couple of things to be mindful of when you are doing this. Okay, and the first thing is that you want to try and get your fingers and stuff out of the sensor's way. So my suggestion would be you'll have the sensor here on the back and you would release it from these little wing nuts here. Okay, have your hands underneath so that the sensor doesn't see them. Just release the cart that way, okay, and then you won't have anybody interfering with your data collection. It's obviously not going to take very long for the cart to get to the bottom of the ramp. You're probably going to have a second, maybe slightly more than a second's worth of data, and that's going to be it. Okay, that's all you're going to need in order to do the stuff we're going to do. The ramp also does not need to be very high. Okay, like a binder, maybe two reasonable sized textbooks. Okay, the three that I have there, okay, just to give you an idea. That's as high as I built that ramp. Okay, it does not need to be any higher than that. If you build it any higher than that, you get less data. Why? It goes faster. Okay, we don't want it to be too tall because if it's too tall, we'll get like 0.2 seconds worth of data, which is about 10 points. Okay, and we need a little bit more than that. Okay, so remember the thing is going to record at 10 hertz. Okay, that means it's going to get 10 data points per second. You can actually change that in the settings if you want it to go to 20. That will give you more data points to graph with. That's entirely up to you. Okay, if you build the ramp about this tall, then you shouldn't have too much trouble getting a good set of data. Okay, questions on the procedure part? All right, I'm going to leave it there. I'll talk about the analysis after everybody has their data. We'll quickly review what we have to do with the data in terms of graphing and stuff like that after the fact. Okay, everyone with me there? So same as before, collect the data, share it with everybody in your group, and then you can get going on the analysis part. Okay, so everything's on the side there, guys. Okay, guys, so just follow along up here so you see what we've got to do with this. Okay, so you have your exported data file that should have been shared with you from whoever took the data in your group. Okay, so we're going to just double click on that. It opens it up like this, which is messy. We don't want it like that. We're going to open it with Google Sheets up here. Okay, Google Sheets will quickly convert it, and then we'll be able to take off the data we need or don't need, okay, as the case may be. So right off the bat, I do not need, okay, row 1. So I'm just going to right click for you guys on the Chromebooks. That's 2 fingers at the same time on the pad. Okay, and I'm going to get rid of that row because we only have 1 run. Then I'm going to get rid of column A because I don't need the date and time. That information is extraneous for what we're doing, so we delete that. All right, and we don't need the acceleration data. All right, so we're going to delete that column as well. Now, obviously, I have some stuff here where nothing is going on for the first little while. Okay, like everything is a 0. I certainly don't need all those zeros in my data. All right, so I am going to delete them all. Okay, so down to about here. And I'm going to delete those cells and shift up, okay, so that everything moves up to time 0. Okay, so I'm highlighting a bunch of that stuff at the beginning where the cart wasn't released or whatever, okay, and I'm making it all go up. Okay, so now it looks like my data all starts right at the beginning. Now, it looks like I also have a couple, actually I could probably delete a couple more here. I'm going to take this one off. Okay, and I'm going to take probably these 3 off right here because they don't seem to fit. Actually, these 4 off here because this is where the acceleration actually starts. So I'm just going to take those off. Okay, I'm going to delete them, shift them up. Okay, all right. So now I've got the data that I need to graph. I need to make 2 different graphs. Okay, one's a position versus time graph, so I'll highlight all of that data. Okay, and obviously I only need to go to the end here to 2.1. And then I'm going to insert chart. I'm going to go fast this time because I've done this before, guys, and I'm recording it. If you need to see it again, you can watch it again. Okay, so I'm inserting the chart. Okay, and obviously Google Sheets never picks the right thing. I want a scatter plot. Okay, that looks pretty good. I've got a slight curving nature to my graph here, which is excellent. Okay, then I'm going to go to customize. Okay, it's even already put in the proper stuff here, position and time on my axes. Okay, I'm going to change the title to, got to spell it right, acceleration lab position versus time, because that's what it is. Okay, then I'm going to go to, actually that's it. That's really all I need to do on my position versus time graph. I don't want a trend line on here. I'm not using this graph to calculate anything. Okay, this graph is just there for its shape when I'm answering one of the analysis questions. So as long as I have this graph built and it looks like this, I'm good. That's all I have to do with that position versus time data. All right. The next thing I'm going to do is I'm going to build a whole new sheet and just put the velocity and time data on it. Okay, so I'm going to copy column A. I'm going to go down here to where it says add sheet. Okay, and I'm just going to paste that in there. And then I'm going to go back and get the velocity data. And I'm going to bring it over here. It's just easier to do it this way because I don't have to worry about that position data getting in my way. And then I'm going to build a velocity versus time graph. Oh, I went too far. Sorry. Okay, so I'm going to insert my chart here. Okay, again, I'm going to pick scatter plot. It's a little wonky, but it'll work. Okay, so obviously this data here at the end is a little bit suspect, but I'm going to keep it on there anyway. Okay, just because that's how much of the position data I kept, I'm going to keep that much of the velocity data as well. It's going to be important for one of my calculations that I have to make in the analysis. All right, so I'm keeping all of this. I'm going to customize now. In this graph, I do want a best fit line. Okay, so I need a trend line for this one. So first off, okay, so we'll go to series here, okay, and I'm going to get my trend line. Right, so it's put it in there. That's good. That's what I want it to look like. Right, I'm going to put in my label here to use the equation. Now I've got y equals mx plus b for this line here. I'm going to need that for some of the calculations as well in my analysis. Okay, everybody with me so far? All right, once you got those two graphs built, then you're moving on to the analysis. Okay, so it should literally not take you much longer than it took me to build those. Okay, you've got the data there. Okay, so once I have those, okay, then looking at what our analysis is asking us to do. Okay, so it says for analysis question number 1, using your graphs, identify the type of motion that occurred, okay, in this lab and show calculations to prove and explain your reasoning. So what I'm looking for here, talk about the shape of your two graphs. Do they say acceleration is going on and why? Okay, so talk about the shape, okay, and why that is indicative of an accelerating object for both graphs. For the calculation part, we said in our hypothesis how we were going to calculate acceleration from the velocity time graph. Show that. Okay, from your velocity versus time graph. So those are the two things you need in your answer for question number 1. For question number 2, you are going to calculate the displacement of the object from both graphs. Okay, there's a way to get it from both graphs. All right, so calculate it from the position versus time graph and then calculate it from the velocity versus time graph. Theoretically, those numbers should be the same. They're not going to be exactly the same, but they should be pretty darn close. All right, you need to just explain, okay, any differences that you might have. This is why I said you need to make sure you have the same amount of time on both your position and velocity versus time graphs. If you shorten your velocity versus time graph by a half a second, you're not going to get the same number for displacement as you did for the position versus time graph because you're talking about a shorter amount of time. We need to compare the times equally. Everybody follow me on that one? Okay. All right, then same as before, for your conclusion, restate your hypothesis, talk about your data, talk about the shapes of the graphs. Do they say acceleration occurred? A little bit of explanation there. Kind of a restatement, a bit of your answer from number 1. Okay, sources of error. Okay, talk about what some sources of error might have been. Okay, think about kind of what the cart did as it went down the ramp. Was it, was the motion smooth? Things like that. Anything that could affect your data, especially the acceleration of the cart, okay, you can talk about as a source of error, mention ways to fix it, and then that's it. The class discussion we will talk about when I hand back the lab. All right, I made it due the 20th. I don't know why I made it due the 20th. We're not here. I'll change that. It'll be not next week because we're not going to be here. I have to change the due date to the Wednesday after that. Okay, that's when it will be due. All right, questions on that? All right, you got the rest of class, which is about a half an hour, okay, to work on that. And hopefully you can get quite a bit of it done and have less homework. Okay.